I had a good time coming up with this title of the presentation. So I'm not surprised to see some 40-ish-year-olds present because of the title. Yes, I will. Who thought this was me? Anybody in this room? It could have been me. Yes. Hey, guys. I had several people say, "Is that you?" And I was just surprised, I guess, because I will admit, they were some older folks that wondered if this was me. But this is not me. Most of you know this is Jan Brady. So no, this is not me, but this is me when I was watching Jan Brady and using my Easy Bake Oven. So notice the hairstyles. I tried to mimic hers. But anyway, I wanted to talk with you a little bit today about the wetlands work that we've been doing at CRD for about the past 12 or 13 years. I'll talk a little bit about that evolution along the way. But most of our work has been funded through EPA over the years, and so I'll talk a little bit about EPA's requirements for the states to accept money and the different projects that we've been working on through EPA funds. There's also been some NOAA funds that have supported several projects throughout the years. But I like to start with this because this diagram really lays it out, I think, comprehensively to be able to think about the ecology of wetlands and how that ecology links in with goods and services. Because more and more I see that it's important for all of us to tie our work with natural resources back to people. And that's a challenge for a lot of us. And so in order to be able to talk about projects and their benefits, we have to really get into the goods and services and the valuation of wetlands. So I like to teach my students it's all about the grass, because none of this would be here if it weren't for this. And so I think wetlands are important for us to study and to build into management. We've got an awful lot of Spartina out there, so oftentimes it's overlooked in terms of its value. And again, coastal Georgia goes back to a very rich history. This is where coastal ecology really started. And back in the 50s, Dr. Odom was able to build this relationship with R.J. Reynolds out on Sapelo Island, and he was able to convince Reynolds that Sapelo was a great place to birth this ecology group. And the Marine Institute came into play, I think, around 1958 or so. Do you know, Kathy? Somewhere around that time. Oh, you know Brooke. 53, so a little bit before that. Sorry, Brooke. I can't believe I overlooked you. But nonetheless, we have a solid foundation for which to base a lot of the work that we do regarding wetlands and their importance. And so we have, since about 2012, when we first got into studying the grass, we have built upon that, and it's important to keep up with that foundation so that we're bringing science in to a managing agency and being able to really make that make sense going out the door in terms of policy. So through EPA, each state that EPA funds is encouraged to create a wetland program plan. And that plan is going to be released to EPA later this fall for Georgia. And it's important to point out that our freshwater wetlands and our tidal wetlands are managed by two different divisions within DNR. And so we will have, the state of Georgia will have a coastal tidal wetlands plan and a freshwater wetlands plan for the state of Georgia after ours is approved by EPA this fall. So we can accept monies a little bit more non-competitively, yet still competitively through EPA when we have an approved plan. So EPA requires that we have 4 core elements that are addressed: monitoring and assessment, restoration and protection, and regulatory activities and water quality standards for wetlands. So that's what we're looking at as a foundation for creating our plan. But today I'm going to talk about monitoring, assessment, and restoration work, because those have been the 2 elements that we've focused most of our time on. So I'll highlight those. And then these are several projects within those two elements that I'll speak about. But I do want to point out that a lot of these blend. So living shorelines, wetland edge sampling, I'll get into that a little bit more, but those bleed into restoration concepts. And all of this bleeds and feeds into regulatory activities and policies and potential policy changes as well. Water quality standards for wetlands we're thinking about. We've got some monitoring in place, but we're not quite there yet. And most states do not have water quality standards for wetlands. So it'll be a long while before we actually see those come out. So what kicked us into grass sampling? It was the dieback of 2002. So in 2002, when we first started getting reports of areas of Spartina and Juncus Marsh that were dying off, someone had to respond. And so CRD responded because that's what we work to manage. And so we got a lot of publicity out of the 2002 dieback. But we learned a lot about how to receive calls, how to get that information and get it as quickly as possible, keep the lines of communication open with the public. And so we started by working with our top people. We put our top people on the job, of course. And this is what we started out with, a lot of field monitoring. And so at that time, the Georgia Coastal Research Council was just being formed. And so we brought together that group of scientists to study this epidemic, this actual topic of marsh dieback. So we've got Steve Pennings and Susan White here, who's gone on to be the director of the North Carolina Sea Grant Program. We had a lot of support from Savannah State, UGA, Skidaway, Signer, you name it, a whole host of partners that were interested in learning about these sites. So we fielded hundreds of calls that year and in 2003, did a lot of field sampling and devised a protocol of which to use. At that time, we were monitoring quarterly. Several years after, we started monitoring annually for dieback. Notice a lot of these people have gone on to be someone. Fred Hay with the reserve. Some of you know Ben Maher from Savannah State. Brooks Good, he left the state, found his private business. Anyway, we learned a lot that year, or with that, those calls coming in 2002. What is the cause of dieback? That's the million-dollar question, right? We feel like it's related to drought, and that's what the data suggested. Although you can see that our salinities, our pore water salinities, never really exceeded about 35. And so the actual mechanism of what killed those plants is still unknown. There are a couple of theories out there. One primarily driven by a change in pH in the marsh, and the pH caused a higher mobility of metals, naturally occurring metals possibly, in these dieback areas, and so the plants were not able to keep up. The xylem vessels were being clogged. What we would see is just basically a stalk of Spartina that remained. And so we have over time, and these are just a couple of photos to show from early dieback. 2004, you can see transects. For those of you that do sampling, this is in the dead transect that doesn't look dead anymore. You know what I'm talking about, Sonny. 1, 2, and 3. And then in 07, you can see that was 2. That was our quad 2, completely different marsh. So again, this is a fairly significant dieback and a fairly quick recovery. So pretty amazing. But a part of our job now is to keep up with these calls, to investigate what the dieback could be, and a lot of it's attributed to rack accumulation. And so that's an important thing to communicate to a property owner is, yes, the marsh is dynamic, this whole system is dynamic, this is rack dieback, and it'll move off whenever we have another high tide come in. And so that communication is extremely important to keep open. So in 2013, we had several reports, as we have along throughout the years. We've continued to have reports. And so if they're suspicious looking sites based on the information the caller gives, then I'll go out and talk with them and take pictures and things like that. So that's our story of dieback. So now I want to jump into living shorelines a little bit. Back in 2006, we applied for funding to look at alternative stabilization techniques for tidal creek shorelines. So what we wanted to think about is going from a vertical or a revetted bank to something that had more habitat value. So how can we bridge the need for stabilization, a stabilization technique to combat erosion, with something that provides more habitat than what this provides? And so that's when we explored living shorelines as an alternative. And what does living shoreline mean? And we're still not solid on a definition of what living shoreline means, but we know a lot more about what it means now than we did years ago. So we have to date conducted 3 pilots. The 4th is in process, going through the regulatory process right now. 2 of these are on Sapelo. Our 2 demo sites, our first 2 demo sites were on Sapelo Island, Post Office Creek. This is the one that we refer to as Ashantilly. And so there's another one just up at Long Tabby that we call the Long Tabby site. So they use 2 different techniques to create this living shoreline. This site, you can see the erosion before, eroding at approximately a foot per year, and you can see how non-uniform that is down the bank. This is a post-construction picture. The site used about 8,000 oyster bags, sloped 2.5 to 1 or so down the shoreline, and then we went back and planted Spartina, and then some other transitional plants like Barrickia, Peytons, and a few others. And we're continuing to monitor these. We have worked with a host of partners, Sapelo Island Reserve, UGA, Wildlife Resources, the Nature Conservancy, to all bring expertise to the table and funding to where needed to be able to monitor these projects and create the best design that we know of. The 3rd site was on Little St. Simons Island. That one was just completed last year in 2013. It used about 10,000 oyster bags. And this one was a little bit different in that it created pockets of Spartina along the bank. So there wasn't sort of this transition that was uniform along the bank moving upwards. This created little pockets of Spartina. And then you can see also that the shell is a little bit higher than it would need to be to recruit oysters. That is a part of the learning curve, is figuring out where that elevational change needs to be, sort of the sweet spot in terms of where we need to cut this off so that we don't waste shell, but also have some sort of material that's going to help stabilize the bank. And so another difference in this project site versus the others is the bottom layer of oyster shell was wrapped in a geogrid fabric, or plastic basically. And that is to create sort of a mattress along the bottom of the structure so that there would be no sloughing of bags off of the shoreline if there were a storm or whatnot. If anything happened here, the whole thing would go. And so I think that's a better way to engineer this. So with the 4th project, which will be at Cannons Point, that will also incorporate some of these lessons learned on previous pilot projects. So what about the habitat? Is this a better habitat than other types of bank stabilization techniques? We think so. There's only, again, been a couple of events of post-monitoring. So for pre-monitoring and post-monitoring, we're doing both transects up and down the shoreline here to measure aquatic invertebrates and to look at plant communities and how they are transitioning. But we're also looking at fish habitat. So by using these bottomless lift nets, we can actually see what is using this area. And of course, I teased out the 4 species that show an increase. But the big numbers were in these important, what I would consider to be some of the important species. So that's why I wanted to highlight these. We've got grass shrimp here, pre-construction numbers versus post-construction numbers. You can see the increase. We've got white shrimp here, 23 to 318. Again, this is only one sampling post-construction, but it looks pretty good so far. And then we've also got bay anchovies here, which are showing an increase. So these grass shrimp are really laying the foundation for some of the life cycle within the marsh. And so I think that that's important to show those increases. We did show some decreases on things like blue crab. We went from 8 to 2, and some other species as well. But again, it's one snapshot. So this will continue for 3 years to be able to show a 3-year window of what's happening in this area. We'll continue the transect monitoring. We'll hope to use the lift nets where we can on projects in the future, but also we want to move into monitoring using terrestrial LIDAR. And Dr. C.J. Jackson at Georgia Southern has used terrestrial LIDAR to monitor shoreline change in different locations. The beauty of this technology is that you can pick up millimeter accuracy and change over time. And so it's going to be a nice benefit to be able to pick up all these little changes along a shoreline in a given area. So he'll ultimately, and the goal is to be able to quantify the changes in oysters over time and also look at the plant communities over time. So we'll be able to tell if the engineering is holding up, but also what the biological activity has been. And so that's going to be a project. He's actually got it underway now. He's got a graduate student that's working on some of these sites. And it's early, so we won't have data for a while, but nonetheless it'll be a really neat way to monitor in part. And all of this information can be found on our website. It's like a public service announcement. In this summary report that has just been completed, thanks to Nancy and Paul for helping get this together. The summary report is basically the story of the 3 projects that are on the ground. And so it outlines the monitoring, the construction, the design, the results, the project timelines, the outreach activities. Also, it outlines a cost comparison, and that's what a lot of property owners are asking for. What is the cost of a living shoreline compared to a bulkhead or a revetment of certain types? And so all of that is outlined here in the cost comparisons. And so far we've seen that living shorelines are much cheaper than other types of stabilization techniques. But we've also seen that they do require a slope, and a lot of property owners aren't willing to give up their property by sloping it back. So we're constantly working to show what the benefits could be, and also not truly promoting this type of activity because we're certainly learning still, but offering this information where we can to let property owners know what has been done and let them make the decision on whether or not they would like to try something like this. All right, the next kind of monitoring I want to get into is related to impacted wetlands. And the premise behind this is that impacted wetlands, and y'all know this site well, some of you, Little St. Simons Island, channelization causes an alteration in hydrology, which changes your sediments, which changes your geomorphology, and ultimately your biological communities. And so, what is that change exactly? Should we be pouring money into restoration projects in salt marshes? This is trying to help answer some of those questions. What's the gain going to be over time if we move in to restore areas that have been impacted? Now, many of you know that our impacts go way back. We've got a lot of impacts that are really, really old, decades old, from mosquito ditching and so forth. And so at what point does a marsh self-restore? Does it have the same kind of community as a natural area does? And so this is the idea behind what we call the drop ring technique. And the drop ring is basically a design that we have learned about through our colleagues at EPA in the Gulf. Louisiana has used this quite a bit to sample edge habitats. You can sample Spartina habitats, any type of vegetation really. You can sample oysters, you can sample mudflats, whatever type of habitat you choose. The trick is you've got a big ring on a boat, and there are lots of safety issues here, but nonetheless, we've had good luck so far. And so you've got to be able to access these areas. And so we did a pilot last year after we borrowed the rig from EPA. We tested it. We saw it is going to work. We built our own, and we did a pilot last year. And we're targeting larval and juvenile finfish and aquatic invertebrates. So this is a little bit different of a focus than those lift nets that we looked at before. So last year we did the pilot. This year we're going to be sampling marsh or Spartina edge and then moving into oysters. And the oyster areas that will be sampled will be natural reef communities versus restored reef communities. And so this really plays into those impacted sites by sampling channelized versus non-channelized, but also reefs that are natural versus those that are restored. So once you drop the ring, you get and evacuate everything out of it. So everything is pumped through this plankton net in the back, and it's captured in a bag that's at the end of the plankton net. The bag is what is brought into the lab, and everything is keyed out from the bag. And so you can see that there's a lot of work to just get the seal here so that you can actually evacuate. But it's a fairly quick process. Once you get that seal, then you can evacuate out, and it's, again, fairly quick to be able to sample these sites. All right. A couple of other projects that I'll just mention for those of you that might not be familiar. This is a project that EPA does across the country called the National Wetland Condition Assessment. And it is the first ever project to speak on the health of wetlands across the U.S. And so in 2011, it was initiated. Every state got an allotment of sites. These sites were selected randomly from the already established NWI sites and status and trend sites within those NWI polygons. So for Georgia, we received a total of 50 sites. 20 of those were freshwater wetlands, and 30 of those were saltwater wetlands. So we had our work cut out for us to do 30 sites in one summer period. And so, again, here's Ben, here's JT. They were trained up on the protocol, and we had to access some pretty remote areas. But we were looking at a whole host of parameters here, looking at vegetation, looking at soils, water chemistry, algae communities, and then we also did what we call a USA RAM, which is a rapid assessment method, which is to be able to talk about stressors to a point. All of these sites were just points. And so the RAM asks you questions based on the surrounding buffer areas and any impacts to this wetland particularly. So we've got a call in a couple of weeks about when the final report will be released. Again, this was in 2011. And so the report should be released at any time now. And then we have the data sets for these 30 sites. With all of these aquatic resources surveys through EPA, they rotate on 5-year increments. So ideally, if money is available, we will come back and sample again in 2016. Very similar to the National Coastal Assessment, which Dominic heads up. That is 1 year earlier than wetlands, and so they'll be working in 2015 for NCA, and then we'll be working in 2016 for NAWCA is what we call this. Also, to give a shout out to WRD, we have created long-term salt marsh monitoring protocol with Wildlife Resources Division. And again, we have the best people on the job. Eamon's not here, right? So I can pick on him. But the idea behind this monitoring is to be able to look at changes in marshes and upland communities that could be associated with sea level rise or climate change impacts. And so sites have been selected. I think we have a total of 9 up and down the coast. And this was based on a gradient where a lot of communities were captured on the way from the upland down to the creek edge. And so each site was surveyed for plant communities, also elevation with the RTK, and these sites will be revisited every 5 years, if not more frequently. And so we helped to get this off the ground with non-game, but they are going to be taking the lead on the monitoring indefinitely, as long as the funding is available, right, Jason? And then we'll be support staff where needed. And they're going to give us the results, right? Okay. So getting back to restoration and protection, some of that work, like the monitoring with the drop ring, does feed into restoration work. But also we've done an identification of impacted wetlands throughout the tidal wetlands throughout the coastal area. And then we've gone a step further and prioritized those sites on state-managed lands. And then we're also continuing to develop restoration monitoring techniques and looking into restoration science to be able to guide processes like the Army Corps' process. So they require mitigation, which is a form of restoration. The state does not. So how can we positively influence that process? And so this is just one site. Some of you are very familiar with this. We call this Richmond Hill South. This process for identifying impacted wetlands was done primarily remotely, and then there was some on-the-ground truthing. But you can see the impacts here that are fairly extensive. We still don't really know what happened in this area. We think it was something to do with aliens, but not quite sure. But nonetheless, you can see the outlined feature in red here is sort of the larger wetland impact, just the best that we could delineate that at. Then you've got a series of channels and also impounded features, which are the blue and the red, throughout the site. And so we use this to be able to, again, kind of get down into the site a little bit more and figure out why was it impacted and how might we want to influence restoration here. It all gets back to the need. Is there really a biological and ecological need to restore or not? Again, delineated by NWI polygons, it's still salt marsh. So is that good enough or not? And that's kind of where we are in the midst of restoring some of these larger sites. And then I wanted to mention a couple of mapping efforts that have been done several years ago now. Updates to the National Wetland Inventory for the 6 coastal counties. That was a part of our grant in 2006 to do those updates, and we contracted those out. And so now we have 2006 data for the coast for wetlands. The rest of the rest of the state is still working off of the old data sets from the mid-80s. So this was a significant project for us to be able to update this NWI. And then we went a step further with NWI and added descriptors, 4 geomorphic descriptors to each of the polygons to really tell us a little bit more about the wetlands. Where are they in association with the nearest water body? How are they interacting? What is their shape, etc.? So this is also in a report that was put together entitled Wetlands of Coastal Georgia. And it's fairly comprehensive, but it does give you everything you wanted to know about the wetlands in the 6-county area. And then a lot of you might be familiar with the Armored Shoreline data set. That was really something to kind of kick off our alternative bank stabilization project through EPA, the Living Shoreline project. And it was conducted to find out where exactly these armored shorelines are located and how extensive are they throughout the coast. We're currently doing an update to this, and it will be available next fall, fall of 2015, because we're also working with Skidaway Institute to do a shoreline characterization. And so while they are sweeping the coast, this is Chatham County, by the way, while they are sweeping the coast, they'll also pick up any additional armored shorelines that may not have been present in 2006, 9. And then I wanted to mention a few partnerships, but these are more of active voices that we have with some of these groups. Recently, I was asked to be on the SARP steering committee, and so that's been a good outlet to be able to communicate some of the wetlands work that we're doing in Georgia. Also the SWAP revision committee, many of you are a part of that too. Adopt a Stream and Adopt a Wetland board, that has been very active. That's an EPD program that has been in place for a decade or more. And Adopt a Wetland on the Coast has actually, well, it's been longer than that, because Adopt a Wetland on the Coast was birthed in 2004 or something like that. And so we've been doing coastal Adopt a Wetland volunteer monitoring for that long, since 2004. And so that's a very active group. And then the Southeast Wetlands Work Group is a southeastern portion of the National Wetlands Work Group, where we talk about science, we talk about policy, and how to bring our state programs into those conversations. And that's it.